All right, moving on to the last page of the closure. Here we go. So I've got question C, and I'm going to just spare the time, but this is not factorable. If you try to factor it, you're going to get stuck, and neither is this. So once you realize that you can't factor them, then you're going to change approaches, and you're going to try to complete the square. So that's what we're going to do here. Complete the square. And I'm going to complete the square here as well. All right, when I complete the square, I take the middle term and I cut it in half, and I fill in a square. So this is going to be x squared minus 3x minus 3x. And then I can start to write the lengths of the sides. So this is going to be x minus 3 by x minus 3. And then this will be a 9 because negative 3 times negative 3 is 9. So x minus 3 squared is equal to x squared minus 6x plus 9. But I don't want a plus 9. I want a minus 9 at the end. So my square here, the value is too big. And it's too big by a factor of not a factor, but by 18. So I need to subtract 18. If I subtract 18, I'm going to see that x minus 3 squared minus 18 is equal to x squared minus 6x minus 9. And so now I have the graphing form of the equation, and I can put that in x minus 3 squared minus 18, and immediately spot the vertex that it's at 3 comma negative 18. If I want to find the x-intercepts, I can take this form of the equation, y equals x minus 3 squared minus 18, and set it equal to 0, and solve. So this will give me the x-intercepts. So 0 equals x minus 3 squared minus 18. That means that 18 is equal to x minus 3 squared, which means that there's two possibilities. And I'm going to just call it the square root of 18 because it's not a perfect square. So either this is equal to x minus 3, or the negative square root of 18 is equal to x minus 3. And so my first x-intercept is that x equals 3 plus the square root of 18. And my other one is that x equals negative 3 plus minus the square root of 18. There we go. In other words, x equals 3 plus or minus the square root of 18. So x equals 3 plus or minus the square root of 18 is a way of saying both at the same time. So 3 plus or minus the square root of 18. And those are going to be like decimal values, so you can sort of estimate where they are on the graph. And I feel like this is still confusing, so I'm gonna write it like this: 3 plus the square root of 18, comma 0, and 3 minus the square root of 18, comma 0. So those are my x-intercepts. Okay, y-intercepts. Again, the trick is that it's always when x is equal to 0. So since I have this equation in standard form up here, then the y-intercept is always just sitting on the end. So I'm going to go ahead and steal that number there and say that the y-intercept is at 0 comma negative 9. So there's my nice set of answers for that one. And then I would do the same process for the other one. And I'm just trying to check my answers here. Great, okay. Letter D, same idea, not factorable, complete the square. Here we go, let's maybe change colors a little bit. So I got x squared, I got, now 5x divided by 2. This is going to be 2.5x, 2.5x. So this one's annoying, but you just got to go with it, 2.5. And then if I do 2.5 times 2.5, right, I'm going to get 6.25 over here. So this is equal to x plus 2.5 squared, which is equal to x squared plus 5x plus 6.25. And I'm running out of room. It's not even fitting. There we go. Okay, but I don't want 6.25 on the end. I want a 1 on the end. So I need to subtract 5.25. So this is going to be x plus 2.5 squared minus 5.25. That will be my graphing form of the equation. X plus 2.5 squared minus 5.25. So my vertex is going to be at negative 2.5, comma, negative 5.25. We can see that. My y-intercept is going to be, I can just steal it off the end. So my y-intercept is going to be right here. It's going to be a 1. So when x is 0, y is 1. And then my x-intercepts, so if I want to take this thing, if I want to get x-intercepts at y equals 0, right? So this is going to be x plus 2.5 squared minus 5.25 equals 0. And I'm going to solve. So this means that x plus 2.5 squared is equal to 5.25. Take the square root of both sides. This gives me two possibilities. So either x plus 2.5 is equal to 5.25, or x plus square root of 5.25, or x plus 2.5 is equal to the negative square root of 5.25. And then I'll subtract 2.5. So x is equal to root 5.25 minus 2.5 is my first x-intercept, or from here, x is equal to negative root 5.25 minus 2.5. I'm going to flip them around. It might be a little bit easier to see this. Negative 2.5 plus or minus the square root of 5.25, comma 0. That includes two x-intercepts. So negative 2.5 plus or minus the square root of 5.25. All right, finishing it up here. We're going to factor. So we got 2x squared and negative 4. You're going to multiply them together to be negative 8x squared. And then take the bottom number and put it here. Two numbers that multiply to 8 and add to 7, so it's probably going to be some sort of 8x and 1x. If that was a negative 1, then they would multiply to negative 8 and they would add to 7. So I'm going to take these two things and stick them in here, 8x and negative 1x. I'm going to write out the lengths of my sides. 2x and x makes 2x squared. This is going to be a negative 1. This is going to be a 4. And then 4 times negative 1 gives me negative 4, so that makes sense. So these factors are 2x minus 1 times x plus 4. And that is the final answer. All right, over here, before I factor, I always want to check to see if there's a common factor. And if I see a bunch of even numbers, I immediately know that I can divide everything by 2. So that's what I'm going to do. I'm going to divide all parts by 2 and then multiply by 2. And so I can rewrite this thing as 2 times 4x squared plus 12x plus 5. And now I have something that's simpler to factor because I can just focus on this part. So here we go. I'm going to do 4x squared in the lower box, 5 here. I'm going to take the product of those two, which is 20x squared, and on the bottom I'm going to copy the 12x that was from here. And I need two numbers that multiply to 20x squared and add to 12x. So, for 20x squared, I'm going to think about 1 and 20, or 2 and 10, or 4 and 5, 5 and 4. And so I can see a combination right here, 2 and 10, that will multiply to 20 and add to 12. So I'm going to go 2x and 10x. And so now those go in here, 2x and 10x. And so I'm going to call this 2x times 2x. That'll be a 1. And this will be a 5. And so now I've got 2x plus 5 times 2x plus 1 as my final answer. Oh, I did the classic mistake. Remember, I factored a 2 out in front originally, so I've got to bring that back here into my final answer. So now it is called factored completely. All right, let's do some function notation for number 80. This means that x is going to be equal to 5. This means that x is going to be equal to 2m plus 4. And this means that y is equal to 9. So g of 5 is going to be equal to 5 plus 1 squared, which is equal to 6 squared, which is equal to 36. So we got that, okay? G of 2m plus 4 is going to be equal to 2m plus 4. That's my x. But then I've got the plus 1 squared. So I'm taking like all of this stuff and I'm plugging it in here for x. And so this becomes 2m plus 5 squared. And if you multiply, so this is 2m plus 5 times 2m plus 5. And if you use distributive property, this times this, this times this, this times that, this times that, you're going to get 4m squared plus, you're going to get 10m plus 10m plus 25. And so you're going to get 4m squared plus 20m plus 25 as your final answer for that. Lastly, now we want to solve for x if g of x is equal to 9. So now I'm going to say 9 is equal to, and I'm hiding the original equation over here, x plus 1 squared. So I'm going to go ahead and solve for x by taking the square root of both sides. And so this has two possibilities. The square root of 9 could be 3, or the square root of 9 could be negative 3. So I'm going to say either 3 is equal to x plus 1, or negative 3 is equal to x plus 1. I'm going to subtract 1. So I'll get that 4 is equal to x. Sorry, 3 minus 1 is 2. 2 is equal to x. That's my first solution. Or as I subtract 1 here, I'm going to get negative 4 is equal to x. This means that if you put a 2 inside that function, you'll get a 9 out. Or if you put a negative 4 inside that function, you will also get a 9 out.